So thank you all for coming. So as you can tell and what you just heard, my name is Seemann. I am fairly local here. I don't live in Odense though, but I live in Copenhagen and I do speak Danish as well. If you want to know more about me, apart from that, there's information there on blog.plur.dk, so you can always go and have a look there if you're curious. So this talk, as the title says, is called 3 Data Architectures for the Server. And if you are like most people, you probably just read the title of the talk and never the description of the talk. So let me just give you a little bit of a warning up front. This is not about relational database architecture. So if you expect me to talk about normalization and things like that, that's not this talk. So you still have a chance to go and run for something else if you had an alternative. But this talk is about software architecture and how to organize code. So there will be quite a bit of code as we go along. So with that out of the way, let's get started. So imagine the following situation. So your product manager comes to you and says, hey, wouldn't it be nice if we could, when the user logs into the system, if we detect that the user, that it's the user's birthday, we can show them a little greeting that says, well, happy birthday to you, isn't that nice? So wouldn't that be a good idea to do that? And you go and say, yeah. Let's see what would be involved in doing that, because we don't really have that capability at the moment. So first of all, we'd need to add some UI. And here I've just, for the sake of argument, imagined that we are doing some web-based, HTML-based UI, but it doesn't really matter. We need to write some code to actually add the UI element to that. And then if we're in a context of a statically typed language, which I'm going to assume that we are all the way through here, then maybe you have a class that represents what the user interface looks like. So we could call that a view model or something like that. And you need to go and add the date of birth, data field to that particular class. Okay, so you go and do that, or you think, okay, so that's another thing we need to do. Maybe you also have another kind of model. You have a domain model where you say, okay, so that actually implements our business logic. And we also need to go and add the date of birth, data fields to that particular class. But now we have 2 different representations of the data. So if the user tells us what the date of birth is, we need to translate that into the domain model, but maybe we also need to translate it the other way around. So we need to write some mapping code going back and forth between those 2 things. And we probably want to persist that data in our persistent data store as well. So maybe we have another class that represents what the database looks like, and we could call that an entity, for example, and we need to go and add the fields to that class as well. We need to write some mapping code there. And finally, if we are using a relational database, we need to go and alter the schema to add that column to the table. That's actually quite a bit of work that needs to be done. Now, some of you may recognize this particular scenario. If you've seen this movie, you can find it on YouTube. Some of you recognize it. It's called Microservices. You can go and search for it. Otherwise, the URL is down there in the bottom of the screen, but I can always give it to you. I think we could probably figure out how to upload this slide deck anyway, so you can find that. So that video, for those of you who don't know it, basically runs through this little scenario, and this poor lead developer here tries to explain to the product manager why, because of their microservices architecture, this simple request that the product manager has is entirely impossible to implement because the architecture just basically stops them from doing that. So it's comedy, it's satire, but satire is usually funny if it touches on a sore point, if it actually touches on something that's real. And I think this one actually does that. So you might say, okay, all of that is fine and good and it's funny, but the assumption here is that you have this kind of architecture, a layered application architecture with 3 horizontal layers. And you might say, but that's so naughty. No one writes architecture like that anymore. It's so out of fashion. So surely we've moved beyond this kind of architecture. So point 1, you'd be surprised how many people still do this. Point 2, the reason why they do that is actually because in many cases, it's actually quite a fine architecture, but just typically nowadays we don't draw it like that, we draw it like this instead. And then we don't call it layered application architecture, we call it, ports and adapters, or we might call it hexagonal architecture, or onion architecture, or clean architecture. It's the same thing, it's just a lot of different names. So I prefer the term ports and adapters, but other people use other words, and that's fine as well. Now, to be fair, the original drawing with the 3 horizontal layers, the layered application architecture, is not quite like this. But basically, if you take layered application architecture and do it the right way, you'll end up with something like ports and adapters. So for the purposes of this talk, I'm just going to treat them as synonymous, even though they're not quite there. But for this purpose, they're close enough. All right, but then you might say, yeah, Mark, but no one does that anymore. That's also, maybe not noughties, but that's so 2010s, so no one writes code like that. Nowadays, code should be written as, vertical feature slices. That's the new hotness, which has also been around for like 10 years, so it's not that new anyways, but still. So the idea is still that we think about our system as, basically the top of the system is still the external facing part of the system. This is where our user interface or our REST API endpoints are, and the bottom of the system is where we integrate with all our internal services like databases or email gateways and so on. And if you need to implement a particular feature, you just say, okay, so I'm just going to do that feature all the way through. I'll do the user interface, I'll do the domain, the business logic, I'll do the data access, and all the things that are involved with this particular feature. And then if we want to do another feature, we just do that again. But this architecture doesn't really tell you about anything about what should you do inside of those vertical feature slices. So here you have options. So if you run into a feature that has sufficiently complicated domain logic, maybe it might actually make sense to say inside of that feature slice you actually use the ports and adapters architecture, because that's what you need to do here. So even though you think maybe that's not for me, that might still be some good reasons why thinking about software architecture and how to organize, and maybe separate data representation makes sense. Okay. So what I'm going to do here is I'm going to go through 3 alternative ways to organize data. So I'm going to talk about ports and adapters. I'm going to talk about something we might call the shared data model or the common data model. And the third one is one we might call domain model only. And I'm going to go through each of those in turn. And the point of this talk is to give you an idea about the advantages and disadvantages of each of those. So, I'm not going to stand up here and tell you that one is better than the other, because it really depends on the circumstances. And I'll, try to close this talk out with some to summarize the advantages and disadvantages of each one. So the purpose of this talk is really just to inspire you and tell you there's more than one way you can model data, so pick the one that makes best sense in your particular context. And by the way, this is just the 3 that I could think of. There's probably more than just those 3 models, and that's fine. No problem with that. All right, so in order to talk about architecture, I think it's always useful to have some sort of example. So when I need to do some example in software architecture, I usually reach out for this domain that I know a lot of. So I like eating out at restaurants. So you can imagine for this, the purposes of this example, that we are creating a little software as a service system that implements some management software or management system for managing restaurants. And particularly the subset of this problem that we're going to look at now is how to manage the tables at a restaurant. So not database tables, but how the actual table layout in a restaurant might look like. Because if someone signs up to use this software as a service multi-tenant system that we have here, the person who administers that restaurant needs to tell us, I have that table and this table and so on, so we can know whether we can accept reservations and so on. And to make the problem a little bit more interesting, we're going to distinguish between 2 different kinds of tables. So there's going to be your normal standard table that if you've ever eaten out at a restaurant, which I suppose most people have, you probably know this. So this is where, if you want to make a reservation for 3 people, you'll get a table for 4 people, because most restaurants don't have 3 people tables. And then the 4th seat at that table is just going to be vacant. No one's going to sit there. And the restaurant sort of calculates that into their overall business plan, so they know that tends to happen. But then again, a restaurant may have tables that will typically seat 2 people. They will have some other slightly bigger ones that seats 4, and maybe some that even seats 6. And they may have some business rules that say something like, okay, so if we have a 6-person table, we do understand that we can sometimes run the risk, or we will often run the risk that we can't entirely fill that table, but on the other hand, we don't really want to just have one person sitting there. So maybe we should also give the restaurant manager an option to say, well, we need to have sort of a minimal reservation, so we can say, okay, so we have a table for 6 person, but the minimal reservation is 3. We don't want to accept the reservation request unless it's 3 or more. Just to make the example a little bit more interesting. And then the other option, the other table, a kind of table that we may offer is a communal table like this one. So this might be counter seating, where if you make a reservation for 3 people, you just get 3 of those seats. And then your neighbor to one or both sides will be someone which not in your party, and you just share that table. And that gives you a little bit of a better use of all the table seats in this particular way. So it's a way to increase revenue for the restaurant, actually. And some restaurants will have both, so they will have some counter seating and they will have some standard tables. So we need to, think about a data architecture, or rather 3 different data architectures that can sort of model this kind of problem. So I'll give you a little demo of such a system running, just to give you an idea of what it is. It's not really, I'm just going to show you the system in action. So at this point, we're still not going to look at any code. And nothing particular fancy is going to happen here, but it's just that it's always, because I'm going to show you a lot of code later on, and it's just that if you don't know what the code does, it can be a little bit confusing, because then you're sitting and saying, okay, what does it actually do? So I think it's important for you to just see how that actually works. So I'm going to start the system on a background thread, and it's listening here on this particular address. And it's just a REST API, so I'm just going to do some JSON back and forth with it. And the way that I usually do that is by using curl. And if this had been a proper, oops, don't know why I did that. Let's do it like this. If this has been a real multi-tenant system, you would probably have something like tenant ID here and blah, 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 and so on. But this is just a little bit of demo code. So I'm just going to go straight to tables. And the first thing I want to do is I want to create a new table in the system. I want to define a new table in the system. So I'm going to do that by posting some JSON. And in order to do that, I need a content type of application/JSON. Stop me if I do something wrong here, because sometimes when I talk and type at the same time, I make mistakes. But otherwise, in order to do a post request, we do this little -d, which means here comes the data. That's just the way that curl works. And then we can say something like, we'll start with a communal table, and we'll say that this is an object that has a capacity. And the capacity is, let's just say, this is 12 people that it seats. Does it look good? Okay. Let's see what happens if I press enter. Nothing happens. Oh, that's good. That's not good. It's not really. Oh, so it's actually, there's stuff it doesn't paint. Here we go. And this even turned out to work. So you can see here it says 201 created, so that's fine. It actually created something. It also gives me a location header here, so I can go and say, I can just request that, and then we can get a response back saying, okay, 200 okay, and the data is down there towards the bottom of the screen. Let's just do one more so you can see we can also do the other kind. So instead of a communal table, we'll do a standard table that, for reasons I no longer remember, I called it a single table. That should be a little bit smaller. So let's do one of those tables for 6 that I talked about. And this also needs a minimal reservation. And we say, okay, let's make that for 3 people. And again, you can see that it says 201 created up here. And then we get another address here. So this is just your standard REST API in that particular sense. Oops, see, the The tilde should not be there. Okay, so there we go. So that's basically how that works. Nothing particularly fancy, but it's just then it gives you an idea about what kind of system that we're talking about. So that's the purpose of the demo, just to give you an idea. Now you know what the system does. All right, so the system needs to take those two kinds of tables, either a communal table or a single table, and you'll notice that the format of these two things are a little bit different. And I did that also to make the example a little bit interesting, because now it's not just your basic CRUD, because you need to figure out how to parse and deal with the different kinds of tables that we have. And you often run into these kind of data modeling problems where you need to model data that's sort of heterogeneous, in the sense that the different subcases may not look particularly much like each other. These are not that far apart, but still. All right. So the code that we're going to talk about is C#. I'm not assuming that everyone here is a C# developer. If you are, it's fine. If you are not, you should still be able to read the code. I've learned most of what I know about software architecture by reading lots of books by Martin Fowler and people like him, with all their examples in Java. And even though I'm not a Java developer, I sort of figured out what was going on here. So I'm assuming that the other way might be true as well. So I'm not doing anything particularly fancy with the C#, and I'll tell you if I am. Also, I need a web framework, so I'm using ASP.NET, but again, I don't intend this to be an ASP.NET tutorial as such. So again, if you're not normally working with ASP.NET, but you're working with some other web framework, you should still be fine, because the things that I'm going to talk about here tend to be fairly common across various different kinds of frameworks. All right, so again, just to remind ourselves, the requirements here. So we're going to start with one of those two kinds of table. We want to be able to post them. We want to be able to read them back. And so the problem here may not sound particularly difficult, and it's not, but it's just to give us an opportunity to talk about different ways, 3 different ways of organizing the data. So I'm going to start with the ports and adapters architecture, just to give a little brief overview of this. I'm assuming that this is probably the most well-known of the 3 data architectures. So I'm not going to spend too much time on this, but again, it's nice to have a little bit of a review of what does that actually entail. So we might draw it like this, but sometimes, in this case, we might also, sketch it out like this, where we say we start with a view model, for example. That might be one class. Then we have a domain model, and then we have some sort of, object relational mapper. In .NET, we tend to call them entities. And then we need to have some mapping going back and forth between each of these things. So I'm not going to show you all of that, but just going to, show you some sample code that sort of highlights how this works. So we can start with the JSON. If you remember what the JSON looks like, how do we model that in this kind of architecture? And the idiomatic way of doing that in .NET is by having an object that sort of mirrors the shape of what the JSON document tends to look like. So usually I call these objects data transfer objects, or just DTO, so that's why it's called table DTO. And in this case, what I've done here is I've said, well, a table DTO has a communal table property and a single table property, and each of them then has a type. And if you're not familiar with the more modern developments of the C# programming language, that little question mark that sits after both communal table DTO and single table DTO, those type declaration, that means that it may or may not be there. It may not be null. That's basically what that means. So basically what we say here is that communal table may or may not be there. If it's there, it has this particular shape, this particular type. And if a single table DTO is present, it has this particular shape. So pretty much the same, but just with a minimal reservation as well. Now, is this a good data model, we might ask? And then again, the question becomes, good for what? If the purpose is to serialize or represent, how JSON is serialized and deserialized into the system, well, this is just perfect. It hits exactly the nail on the head. This is how you do that idiomatically in C#. It's not the only way you can do that, but this is how it's normally done. And it's a very good model for that particular purpose. Now, on the other hand, if we ask another question, we can say, well, is this a good representation of our domain logic? well, then we just need to remind ourselves what the domain logic is, and I haven't really explicitly spelled it out, so let me do that now. So just to keep things simple, the rule here is a table is either a communal table or a single table. It is never both of them at the same time, but it is one of those two things and nothing else. Also, sort of implied here, we are modeling something in the real world, and numbers in the real world tend to be natural numbers. So even though I've declared capacity and minimal reservation as integer, we can't really accept negative numbers here. So that's also something that we might look at. So with those requirements, if we say, well, we expect numbers to be natural numbers, and we expect a table to be either one of those two things, but not anything else, then this is not a particularly good model of the data. Why not? Well, can we model that we have a communal table? Yes, we set the communal table property to have an object, and we set single table to null. So that's fine, we can do that. Can we model a single table? Yeah, we just turn those two things around, set communal table to null, have a value for the other things. But there are two more things that we can do with this data model that we have here. Well, we can set both of them to null, or we could set both of them to an object. So that sort of violates the requirements here, the domain model. So it's not really a particularly good way of modeling data seen from a domain model perspective. So if you've ever been around a functional programmer, and you are at the moment, if you don't know if you noticed my Haskell t-shirt, but you'll often hear this phrase thrown around, say, make illegal states unrepresentable. So what I just told you about are illegal states. Both of them being null is illegal. That's not legal according to the domain model. And both of them being present at the same time is also illegal. That's not something we want to be able to represent. But with this data model, we can represent those things even though they're not legal. So even though this is a good data transfer model, it's not a good domain model. So whenever you run into this requirement where someone tells you, well, it's either this subtype, or this subtype, there might be more than two, but then that's a finite set of subtypes that a thing can be, and it can't be anything else, you should always say to yourself, okay, I need a discriminated union here. And if you are writing in F# or in Haskell or in Scala or something like that, it's just a one-liner. But if you're writing in Java or in C# like we have here, you're a little bit out of luck. It's not that it's impossible, but it requires that you utilize the visitor design pattern, and that just requires a lot of boilerplate. So I'm not showing you all the boilerplate, I'm just showing you the public API of what such a thing might look like. So here we can see we can try to create one of those things, and then you say, well, but where's the capacity of the table? Where's the minimal reservation? We can't even see those values. Where are they? Well, in order to get at those values, you need to implement one of those visitor things. And then when you implement that visitor interface, you need to deal with both cases. And that takes a little bit of getting used to, but it's actually a very effective and a very type-safe way of modeling that kind of requirement. So that's not really the main point of the talk here, so I'm just going to skip over that, and you can always find a lot of literature, including my own blog, if you're more interested in this kind of discussion. But the point here is basically just that the domain model is radically different from the data transfer model that we saw before. So what does the persistence model look like? Well, here I've used the popular object relational mapper that we have in .NET called Entity Framework. And nowadays it works mainly just by convention, which means I don't really have to implement an interface or inherit from a base class. It's just if I create a class and it follows certain conventions, this basically represents a row in my database, and that means that the object relational mapper can sort of take care of all of that. So that's, again, pretty straightforward. But again, another representation with a different shape than the two others we've already seen. So I also talked about how we ports and adapters requires a lot of mapping code. So I'm not going to show you all of that, just one example. So in the data access layer, if you imagine that we issue one of those GET requests, we have an ID, we want to get the resource back. We need to query the database in order to get an object that corresponds to that ID. So here's a method that does that. It sits on a repository object. And I'm not going to do a detailed walkthrough of the code, but basically at the top of it, before that blank line, we have our object relational mapper in action, where we just go and say, please go and query the tables table. That's a little confusing, I know, but the restaurant tables database table. Go and query that one, get that ID if it exists. If it doesn't exist, we'll have to return null because the row may not be in the database. That's fine. We know that that's a case. And then after the blank line in the middle of the screen there, we have some mapping code where we basically try to infer, is this a communal table or is this a single table? And then we transform, we map the values from the database into one of those things. So mapping code is just normal code. So I'm not going to show you all the other three there are always 4 ways you can map. I'm not going to show you the other 3 here. But there's quite a bit of that in the important adapters architecture. So if you think that that's too much, that's not really, you can't really see that applies to your particular situation, then maybe the important adapters architecture is not for you. Maybe you should go and have a look at something else. So I will talk about advantages or disadvantages of each of these models when I've done with all 3 of them. So I'm just going to move on to the next one. So this one is basically an answer to some of the problems that we run into with ports and adapters. So we often saw this kind of diagram 20 years ago. So people would talk about architecture and they would draw this 3-layer diagram, and then they would acknowledge that often having a model of what the data looks like in each of those layers tends to be quite bothersome. So they'd suggest that, hey, maybe we should just have a shared data model that is allowed to travel across all of these 3 layers. So the idea is still that you have one object that is an instance of a particular class, and maybe the data access layer instantiates that one by reading data from the database. And then once it's done whatever it needs to do, it passes that object up to the domain logic layer, and the domain logic layer can do something with it, and then that can pass it up to the UI layer, and then does something with it. Or it might go the other way if you have input coming in from the user. What often happens with this kind of architecture is that it ends up looking like this. Because once you allow that data model to travel back and forth, the explicit distinction between those 3 responsibilities of UI and domain model and so on tends to blend together in a sense where that doesn't really, it becomes very difficult to distinguish what happens where. But still, it's worth considering what that data architecture can do for us. So what does it look like? Well, it's pretty simple. I started out with the entity framework class again, so that object relational mapper, and then I modified that afterwards. So we'll see that since my initial starting point was the entity framework model, we have database concerns taken care of here. We have very little domain logic in the sense that we're just using whether or not minimal reservation has a value to infer whether this is a single table or a communal table. And in this case, I could get by with just doing this kind of inference. But if you have something where inference is not enough, you may need to actually save a type discriminator as a column in your table. So that doesn't really change the overall story there. And you'll also notice that I had to add these JSON ignore attributes to 2 of the properties because I don't want to serialize into JSON ID and public ID. So that's the way to tell the JSON serialization system that it shouldn't do that. Okay, so we have everything mixed in together in this particular one class. We have UI concerns or external API concerns. At least we have a little bit of business logic. We have data access concerns. Everything mixed together. So this goes against a lot of good rules for software architecture, but on the other hand, you can't really deny when you see how it's used that it's pretty simple. So how do we query the database? Well, we just go and query the object relational mapper and say, okay, give me from the tables table, give me that one, return it. Okay, done, fine, moving on. How does the calling code look like? So if we need to handle a GET request, for example, we might write a method like this one. So in ASP.NET, we call those action methods, and you'll notice it's adorned with this HTTP GET decoration there. So we do a little bit of input parsing just to figure out if the ID is actually a GUID. Then we just call the repository, ask it to read that particular GUID, and then we get that table back, and that table represents a restaurant table on all kinds of different levels, so also on the UI level. So we just take that, package it into something called an OK object result, and return that. So that's just the way to saying we're going to return 200 OK, and whatever this table thing serializes into is just going to be the body of that HTTP response. So, done. Woo, that was easy. Now, what does it look like, though? So if we return a communal table, it looks like this. If we return a single table, it looks like this. Is that OK? Should it look like that? That's not what we started out with, at least. We wanted the thing on the right-hand side. We wanted these nested things, but that's not what we get. Is that a problem? It may or may not be. So again, whether or not you should choose one architecture or another is depending on the kind of problem that you're trying to solve. If you're trying to solve the problem where you have to create a REST API that has the format on the right-hand side of the screen, then yes, this is a problem. Now, on the other hand, if you're creating a system that's just a little back-end for front-end for your own front-end, and you can just say, well, OK, so these two representations here are isomorphic because they contain the same data. We can just as easily use the one on the left-hand side than the one on the right-hand side, then that's probably not a problem. So why be very specific about insisting on a specific format if it's just for your own internal consumption? You can just say, yeah, I can consume the thing on the left-hand side as well. That makes sense. Let's just go with that. Okay. The point is just that this kind of architecture, this shared data model, tends to be quite inflexible in the sense that the shape of the data needs to be the same all the way through all of those different layers. And if you can live with that constraint, you can use this model. If you can't live with that constraint, it doesn't work. Okay. So the last thing we could talk about is what we might call domain model only. And this might also give us a little bit of a sense for how might we solve a problem like the one that I just talked about. The problem of if the shape of the serialized data doesn't look quite like we'd like it to. One way to do that is the idiomatic one with using data transfer objects, as I already showed you. But there's actually another way to do that as well. So the idea here is that we retain the static model, the statically typed model of the domain model and domain logic, but then we write functions or methods or just plain code, basically, to implement the other concerns. And this might seem a little bit counterintuitive when you first see it, but it does have some benefits, but it also has some drawbacks. And we'll get back to those later on. So the domain model, I basically just retain the same domain model as I had before in the ports and adapters architecture example. This is, again, my visitor design pattern-based discriminated union. But before we move on, I want to start and just ask you a bit to consider just how opaque this kind of design is. And I mean opaque in the sense that you know that a table is either a communal table or a single table. And if it's a communal table, it has a capacity. If it's a single table, it has a capacity and a minimal reservation. And you can't tell that that's the case, from just looking at this particular, API. In order to get at those things, you need to implement that visitor thing, and that's sort of like a moving part, if you will. It's not just something that is statically accessible, so you can't really have any tool that sort of goes and just analyzes this thing and figures out how to serialize it. You can't just have your reflection-based API go and look at something like this and say, oh, I know how to serialize this into JSON, or I know how to serialize this into a row in a database, because how should it do that? This is very opaque. So how do you program against a thing like that in order to still solve that problem? All right, so if we want to read from the database, you know what? We can write SQL, and not to beat another dead horse or anything, but I recently wrote a blog post where I talked a little bit about knowing some fundamentals, and it seemed to resonate with a lot of people. But I learned SQL in the previous millennium. That's amazing to be able to say that, right? 1,000 years ago, I learned SQL. Oh, that's not quite the same, but anyways. But I learned SQL a long time ago, and it's still relevant. It's still useful. Well, there's different dialects, and I just recently had to do some work on Postgres, and that's not really a dialect that I was used to, but I picked it up in a fairly quickly. Try that. Try SQL. It's good. It's fine. So here we're just preparing a query and making it a parameterized query by defining this little @id, and then the implementation of the read method on our repository is fairly low level. So in .NET we call this ADO.NET, and it's also been around since .NET 1.0, I think. And in other languages and other platforms, you have something similar. So I've seen code on this kind of this level of abstraction. I've seen code like that in Python. I've seen it in C. I've seen it in Haskell. I'm fairly sure that Java has something on that level of abstraction as well. So the idea is basically just you start by preparing that SQL statement, you bind those parameters so that you don't have a SQL injection vulnerability. Then you issue the query, you get back in .NET you get back a data reader. This is basically just a little iterator over the rows in the data set you get back, and then you can index into each column on the row by just going angle brackets and then just the string, the name of each column. Pretty straightforward, and you also need to do casting because it doesn't know what type it is. So this seems a little bit, why would you want to do that? That doesn't seem like it's type safe, and it seems very low level, but it does come with some other benefits. And I'll get back to what those are later on. But that's sort of like the thing. We can do this, and then we don't need to have we don't need to define a model. We don't need to define a class of what does the data look like in the database. We just do this. It's just plain code. It turns out to be fairly easy to maintain, actually. So what does it look like if we have, from the calling side, if we go back to the MVC controller that we looked at before, and it's basically the same. And that might be a little bit surprising to us because we say, okay, so how do we implement that get method or that get request? And we just say, we'll do the same as before. We'll ask the repository to get us the table. The table is that opaque object that I just talked about before, that I reminded you of how opaque it is. And then we just return it. And you say, okay, but how does that serialize into JSON? And this might actually, we can make things a little bit more mysterious even, because we might also say, if we can look at how we handle the post method here, the post request, and the same thing is going on. You can see in the post method declaration, we just take a table as input, and that table is that opaque domain model. It looks like it just comes straight out of the HTTP request, and then you go, but how does that work? How did we deserialize? How did we pass the JSON into that very opaque kind of object? It's immutable and everything. How does that work? So this is where things get a little bit framework specific. In ASP.NET, what you can do is you can add something called a formatter. And again, if you're sitting here and you're not doing ASP.NET development, but you're doing something on another web framework, on another platform, I bet that your web framework has a similar extensibility point, because web frameworks in general need to have a mechanism for serializing and deserializing byte streams. And those mechanisms tend to be extensible because a framework author can never predict all the kinds of formats that you need to deal with. So you must have some sort of way to go and define your own. Imagine if you want to deal with, you want to write a web service that can accept that people can post comma-separated values, except that the comma-separated values are not separated by commas, but by semicolons, something like that, or by vertical pipes or whatever it is. You run into those data formats from time to time, and you need to be able to extend the system to handle that sort of thing. So most web frameworks do have some sort of extensibility point where you can go and extend that system, and that's what I've done here. So in .NET specifically, it works the following. First of all, we need to just do we implement a little predicate where we say, okay, I'm just going to tell the system whenever the framework asks my formatter whether it can handle a specific request, it's going to ask me, can you handle this particular type? And then I'm just going to say, yeah, I can handle it if it's a table, but otherwise I can't. And you can do the same thing so one for the input and one for the output formatter. When you implement these things, at first you just get a byte stream, and then you need to figure out to consume the byte stream and turn it into a Unicode string or something like that. But once you get there, you can write code like this. And again, it's sort of like a more low-level API. So here we're just working with an abstract syntax tree. And again, most languages have an API that looks like this for handling JSON. I've written code like this in Haskell as well, so that exists there, and I'm fairly sure that we'll find that in other places as well. So we just say, well, let's pass the JSON. The JSON variable here is a string. Let's just try to parse it. The node that we get back is an abstract syntax tree, and then you just go and query this abstract syntax tree. You say, okay, do you have a node called communal table? Oh, if you do, then I expect you to also have a property called capacity, and I expect that to be an integer, and now I can create a communal table out of that. Otherwise, I can go and ask the abstract syntax tree, oh, do you have a node called single table? And then we'll proceed in the same way. Again, a more low-level approach to things that is less typed, but also saves a little bit of type declaration up front, which is sometimes an advantage. So that's how we parse JSON. How do we serialize JSON? How do we return JSON from a table? We just go the other way. Here's just one example of that. So it's an implementation of that visitor design pattern that I showed you, but just only one of those methods. The one that's most complicated. And here we just go the other way. We build up an abstract syntax tree, and after we've done that, we just tell it to serialize itself into a JSON string, and then we return that as part of our HTTP response. So not that difficult, actually. All right. Let's see where that puts us. So just to recap here, so instead of having a lot of statically typed, statically defined classes that represents what things look like on the wire and in the database, we just write functions or methods or whatever you want to call them. So I tend to be able to predict the reaction that some of you may have now here. I say, well, but I like static types. I want to have my static types representing what the external boundary looks like, what my domain logic looks like, and what my database looks like. And I get that. I like static types as well. Again, my favorite languages are Haskell and F#. It has much more powerful type systems than C#. And that's one of the reasons I like those languages, because it gives me really, really good modeling power. But then again, now I'm telling you that, yeah, you should at least consider not using static types at these particular places in these particular roles. Why? Well, one of the problems with having static types here is that, at the boundary of the system, types are kind of an illusion. And I'll tell you what I mean by this in a moment. But just to be sure that you understand what I mean by the boundary of the system, we can think about this, often draw the system as a circle or a blob or whatever, and the boundary is where the system meets the rest of the world. So this is where you get incoming HTTP requests, or where the user clicks on a user interface element, or this is where you go and query your database, or add data to the database, or send email or whatever. Whenever your data leaves your process space in order to do something with another process, maybe on the same computer, maybe on another computer. Now, when that happens, that communication channel is not typed. It's just a stream of bytes. And all sorts of weird things might happen there. And sometimes you have frameworks that can take care of a lot of those problems, but sometimes you still need to deal with those things yourself, because there might be things that are formally correctly shaped, but still illegal according to your particular rules. So I'll give you an example about why at the boundary of the system a static type may be an illusion. I'm not saying they're useless, that's a different distinction, but at least why they're not real, if you will. So in order to do that, we'll imagine that that things happen over time from left to right, as we do in the Western culture. And we can imagine that we start with two programmers, Alice and Bob. And this is not a security tutorial, but I just still like to talk about Alice and Bob anyways. So Alice and Bob needs to develop a system that talks to a database. And they start out by defining the database schema, and we can call that version 1.0 because that's the first version. Makes sense. And Alice is the one who does that. She also creates a statically typed data model to model what the database schema looks like using her favorite object relational mapper. So you can define your database schema, and then you can run some tool that auto-generates all of those classes for you. And I believe Entity Framework can also go the other way around, where you can start by writing all the classes, and then it'll generate the schema. Does anyone do that? Yeah? Isn't that scary? I mean, it's awesome. Okay, fair. But anyways, I'm impressed by your bravery, but that's fine. It doesn't really change the story here. So whether you do it one thing first and then the other, or the other way around, doesn't really change the conclusion here. So at the beginning, Bob and Alice agree on what that static type looks like, so they can just write code against that particular statically typed model. So that's really convenient, when you want to query the database, you say, oh, give me all the restaurant tables where something is true and where minimal reservation is more than 3, and you get type information, and then you get back a list of tables, restaurant tables that is. And you can go in and for each over them, and you can say for each table, and then you can go table dot, and every time you go dot, the IDE gives you a drop down with all the properties that are available on that particular object, and you say, oh, you can go dot dot capacity or dot minimal reservation or whatever, and it's nice, it's convenient, it's statically typed. Why don't you like that, Mark? And it's not that I don't like it. I'm just saying it's not safe in the sense that if you think it's type safe, that's a lie. It's convenient, yes, but type safe, no. Why? Why is that? Well, because later on, Alice makes a change to the system, and it's a breaking change. She changes how the database looks like, and she creates for herself a new statically typed model of what that database schema looks like. But Bob is not aware of that, so he just keeps on working with version 1.0, and his code compiles. And even if he's written automated tests against that object model, the tests compile and the tests still pass. But if he tries to run this code now in production, it's going to crash the system. And then I'm going to ask you, so which definition of the database is the truth? And I would claim that it's not the static types that represent the truth. It's the database that holds the truth. And I know that there's all kinds of processes you can take in order to alleviate this problem. You could say, but Mark, you should just use continuous integration, and then Bob would discover that very quickly. And I think that's an awesome idea. Yes, you should absolutely use continuous integration. I'm just trying to get across the point that static types, when you're trying to model something that sits outside of your process space, those static types are an illusion. They're a model of what the real world looks like. They're not the actual thing. Now, it doesn't mean that they're not useful, as George Box said about a completely different thing. All models are wrong, and some are useful. So if you still, after you've heard this tirade about whether or not you should use static types for your database access, if you decide, I still like to have my types, I want to use my object relational mapper, that's fine. This is a talk about alternatives. I just want to outline the things you need to be aware of before making a choice. And then once you're aware of this and you still say, I want to use my object relational mapper because it gives me nice, convenient, type ahead, drop down, whatever we want to call it, that's fine. But then you now made an informed choice, and that's really all I'm here for, just to help you make a better choice, more informed choice. All right. So we have some time to catch up on the advantages and disadvantages of each of those models. Just to summarize here, the idea about that domain model first thing here is to just model the domain because that's internally consistent, because that's just how we've decided to model the domain logic inside of our process. So that never leaves our process space. But then everything that might leave our process space, we're aware that this might probably not be how the real world sees things. And then we can, sometimes when we write code instead of types, we can be a little bit more robust and write some code that's more flexible and can deal with more error cases and edge cases than we can with a static type. Yeah, all right, so let's go. So we'll summarize with this very nice and beautiful little matrix here. Maybe the most boring slide of the talk. But let's go through it anyway. I think it's important. So ports and adapters, what are the advantages? First of all, you have very good separation of concerns with ports and adapters. So if you are in a situation where, as I started out, I have 3 different views of what the data looks like, and they have very different shapes. You know, in the JSON case, I had this little nested JSON document, but then I had this, very opaque visitor-based implementation as my domain logic, and then I had a more, traditional, normal table-like looking thing as my entity thing. If you have those very different, differently shaped representation of the same data, and you want to be able to vary them independently of each other, that's what separation of concern means, then this is a really good architecture for that. But you'll also notice that this example that I started out with, this thing where we want to add the date of birth, here we are not varying the things independently of each other, we are varying them together, and that's a different scenario. Anyways, this is also a very well-described kind of architecture, so you can find lots of resources about how to implement and do that and what not to do and so on. There are books, there are video courses, there are conference talks and everything you'd like to see on that topic. On the other hand, there's a lot of mapping going on. So again, if you recall back, if you recall back that date of birth example that I started out with. Now there's, let's just count it again. You need to add a UI element. You need to add the field to the view model, to the domain model, and to the data model, and also to the database. So that's just 5 things. And then you need to have 4 different kinds of mapping. You need to have mapping from the UI to the domain logic and back again, and also from the domain logic to the data model. So that's 9 different places you have to go and visit in order to implement a little feature request like that. So we have a name for that kind of design, or this kind of observed behavior, and it's called shotgun surgery. And there's a book called Anti-Patterns, and you can find a description of shotgun surgery there. And basically, the reason why it's called that is because it looks like you just fire a shotgun at your code files, because it's just, you just have to spread your edits over a lot of different files. And that tends to be a smell if you have to do that a lot. So if you're using ports and adapters in the wrong way, that's a problem with that. Also, ports and adapters, it tends to be a fairly complicated or fairly complex kind of architecture. So I've seen a lot of organizations that claim that that's what they do, but when we go and actually look at the code, everything just seems like it's coupled to everything else, and you don't really have good separation of concerns in practice, and it's really more like a big bowl of mud than actually a ports and adapters kind of architecture. So it requires a lot of discipline to get this kind of architecture right. So that's also something to be aware of. That tends to be a general theme of all of those. Good discipline. If you don't have good discipline, everything is going to go wrong, no matter what you try. Anyways, the advantage of the single data model is obviously that it's simple. There is no mapping. So for something like that, birthday example that I talked about at the beginning of the talk, this seems like a fairly good candidate because a user, often you need to keep track of a few things about a user. The user ID, a username, maybe a password hash, never the real password, right? Maybe a date of birth, maybe a couple of other pieces of information about the user. And you typically don't have a lot of business logic, if the user mostly just exists in order to be able to log in and out of your system. So if you're implementing, a vertical feature slice, that says, well, we just need to be able to deal with a user, change the user's information if the user wants to change that information, query the database for the user and things like that. Maybe you just want to use this data architecture for that kind of problem because it's sort of like a very common CRUD kind of problem, create, read, update, delete. Not a lot of logic involved with that. So fairly good candidate for that, but don't use it in all places because first of all, it's a little bit inflexible. I talked about that, but also maybe more problematic, it tends to create these kind of God classes. So that's another anti-pattern. A God class is a class that just, basically has a lot of methods on it. So maybe you have this little data model and it starts out being 20 lines of code, and a year later it has 5,000 lines of code, hundreds of different methods and properties on it because you need it to be able to do everything and make your coffee. Again, you need to have quite a bit of discipline in order to prevent that from happening. So if you decide to go with that particular kind of design, you really need to be able to say, well, let's keep it small, and if it starts to grow and be bigger, at that point you should probably say, well, before it grows out of our hands, we should probably refactor this to one of the other designs instead. Okay. So the domain model only here, so this is a little bit misleading here because I wrote less mapping, which is obviously false if we compare to the single data model because there's obviously more mapping in that one than in the single data model that doesn't have any mapping. So maybe I should just have written less code, but again, less code than the ports and adapters and not the other one. The reason why we have a little bit less code here is we end up with approximately the same kind of mapping, so I really should change this slide. I apologize for the confusion. But we have fewer data declarations, and sometimes those statically typed data declarations are useful, and sometimes they actually tend to be in the way. And if they're in the way, then let's not have them. This also gives us the ultimate of flexibility. So if you imagine, you probably don't run into this kind of requirement every day, but it's nice to know that you can deal with these kinds of requirements if they occur. So imagine that you have to create some sort of web API. I do a lot of work with REST APIs. And when I started doing my first REST API more than 10 years ago, the norm was actually that a REST API should deal with XML. So the first one I did was actually, taking XML or sending back XML, and then later on we got this request that, hey, it'd be nice if it could also do JSON. And we said, oh, okay, yeah, we can do that because REST has something called content negotiation, so we could let the client decide whether or not it wanted JSON or XML, and now we could, serve both things depending on what people wanted or the client wanted. But we needed to figure out a way to say, well, the data transfer object that we use to represent what goes on the wire now needs to have a serialization and deserialization behavior that can serialize to both JSON and XML. And we still managed to do that with a common, with a single data transfer object model for that. But if you imagine that sometimes later on people come and say, yeah, but now we need to do a break and change, so now we have version 1, version 2 of those things, and we still need to do them in both JSON and XML. Now that using a statically typed data transfer object in order to model that kind of thing starts to fall apart, and it'll be much easier if you can just go and parse it directly by looking at the abstract syntax tree, which is actually not as hard as it sounds. So maybe you don't run into that kind of scenario every day, but it's nice to know that that option exists if you run into something like that. Now, you might end up fighting the framework a little bit because if you have a web framework that's opinionated and it wants you to use things with statically typed data transfer objects, then you might run into a problem. In my experience, ASP.NET is actually not that opinionated, so far it seems to be working fairly well. If you have another kind of framework that's more opinionated, you might run into problems with that, and then you need to decide what to do about that. Should you change the framework, or should you just say, yeah, that's not possible? So that's one thing. Finally, I know my time is almost up. This might require a lot of testing, because in general, if you take away some static typing, then you'd probably, you tend to have to add more tests in order to cover for the lack of static typing. And then again, you'd say, but Mark, why do you want that, if you can have a static type? But it's just like, again, what happens on the wire, what happens at the boundary of the system is not statically typed. And often I find myself that I want to write a lot of tests to check what happens if input is malformed anyway. And then if I'm doing that, these types tend to be a little bit in the way anyways. Okay, so I could talk a lot more about this, but my time is up, so let's not do that. I will have some time for Q&A afterwards, so let's wrap this up. If you're interested in more about these kinds of things, particularly my latest book, Code That Fits in Your Head, have some of these issues, but this is a new talk. So this with the 3 different architectures is not covered by the book, but in the book you can see a variation of the ports and adapters architecture. There's a code example that runs all the way through the book, so that's an option. Now I have all of this, all the code that you've seen here, I have it already implemented in a demo code base. And I plan to write a series of blog posts about it. So you can go and subscribe to the blog, blog.play.dk, or you can follow me on social media, and I'll always announce whenever I write a new blog post. Realistically, those posts will come out sometimes during the summer or autumn, maybe. But I'll get around to them sooner or later. So that's basically what I had here. So. Thanks for listening to me so far, and I'll be happy to take some questions if you have some.